Rational numbers can be divided. Rational numbers. Some questions about rational numbers. Rational numbers. So we know that rational numbers are the ones that can be written in the form of fractions. So they may be decimals, but that can be converted into fractions. So we call those rational numbers. So we have question 1 here. Just a moment. We need to be able to see the question number. So let's just move this a wee bit to the side and see how that can help us. Okay. Seems like it does help us a bit. Yeah. So we have question 1. So rational number 3/40 is equal to which one of these? Obviously, it's not equal to 0.75. In terms of 40, what is 0.75? That will it be actually 30? 30/40, because that's like 3/3. Yes. Okay. Anyway, let's go back to A. A is not, because why? A is not simply because if we divide 3 by 40, I don't like this font size. My pen size is not really helpful. So if we divide 3 by 40, so let's use the written method where we say 3 into 40 doesn't go. So we put a comma, and of course we add a 0. And then we say 3 and 40 into 30. Still, nothing happens here. And therefore, we add a 0. And then we can ask 40 into 300, how many times? So we know that 4 into 20, 87 times. So we can put a 7 here. You know that 7 times 40 will be 280. And then we so this is the written method. Written method, we keep the 280 in our brain. So 280, and then 300 minus 280, that gives us 20. So gives us 20. So we can put a 20 here, add a 0, and then continue the questioning. 40 into 200, that should go 5 times. So A is not the option. B should not be the option, because we can see that 3/4. So what we have done here, we have actually found the answer. The answer is D. By working this out, we know that 3/40 should give us this 0.075. So the answer here, by virtue of the calculation that we did, is straightforward D, if we have to circle. It's not 0.2, because it's simply not, that's not what you get when you divide this. You get how many decimal places? You get about 2 decimal places, or 3 decimal places. You get 0 something, as we can see here. It's not 0.0212 also. So the correct answer is D. Okay, so for 1, the correct answer is D. By us finding out the answer, straightforward. I think we should do the same thing. So a rational number between 3 and 4 is a rational number between 3 and 4. So this is an interesting one. Question 2. So a rational number between 3 and 4. What about 3.5? So 3.5 is a rational number between 3 and 4. So how do you get 3.5? You get 3.5 by, for example, dividing. So this is not the right approach. The right approach is to calculate each of these ones and see if they fall into the category of a rational number between 3 and 4. So for example, 3/2, is it the one? 3/2. So let's just divide 3/2. So 3/2 is the same as 1.5, right? But we can work that out using a long division. So divide 3 by 2. 2 into 3 goes 1. 1 times 2 is 2. We keep 2 there in our brain, and then say 3 minus 2 gives us 1. So we put the 1 here and add a 0. And then we next put a point here because there's no longer this number. So 2 into 10, we know it goes 5. So indeed, 3 over 2 is 1.5. Is 1.5 between 3 and 4? No, it's not. So let's go to B. And we try out B. So 4 over 3, written method. So we are dividing 4 by 3. 3 into 4, of course, once. And then, of course, we add a 0 here, 3 into 40. We can imagine a number that goes 3 times into 40, 9 goes. So 3 into 10 goes 3 times. 3 times 3, 9. 10 minus 9 gives us 1. So you get 3. Interesting here. So is that what we get? 3 over 2, 4 over 3. Yes, so we get 3. So forget this bit here. The point is, whatever we did here with B, does B give us a number between 3 and 4? No, because it's 1 point something. So that's not the number we're looking for. What about C? Now we know that 7 over 2 divided by 2 will give us 3.5. Let's do it using the written method. So 2 into 7 goes 3 times into 6, right? 3 times 2 is 6. 7 minus 6 gives us 1. Put the 1 here and then put a 10. So we'll put a point because this is an addition of a new digit. So now 2 into 10 goes 5 times. So 3.5 is a number that actually I guessed in the beginning. So this is a number that falls into the category different from A and B. What about C? Oh, I mean D. So 7 over 4. So we are dividing 7 by 4. 4 into 7 goes once. Okay, 1 times 4 is 4. Now 7 minus 4 is 3. Now we put a point here because it's no longer a digit. And then we say 7 minus 4 is 3. So it's 3 here and it's 0, which is like 30. 4 into 30 goes about 7 times into 28. 7 times 4 is 28. 30 minus 28 is 2. Put a 2 here and then put a 0. And finally, we say 4 into 20 goes 5 times. So this is also a number that doesn't lie between 3 and 4. So the correct answer here, folks, is C. That's a rational number that is found between 3 and 4, which is 3.5, 7 over 2. Now, moving on to question 3. So question 3, what is it? A rational number between 3 over 5 and 4 over 5 is, again, we look at this fraction, 3 over 5, so 3/5, and 4/5. So we know that between 3/5 and 4/5, we could have something like maybe 3.1, 3.5 fifths. It's strange to say that, a decimal in a fraction, but actually that makes some sense. Or perhaps we could say 4/5 minus 3/5. We get 1/5, and then divided 1/5 into different parts, and then add to 3.5. But anyway, we get an idea that we need a number that lies between 3/5 and 4/5. We will know that number. Or the first thing we can do, actually, class, let's find out what 3/5 looks like in decimals. That can help us. That might help us. So let's say 3 divided by 5. So, of course, 5 doesn't go into 3. Put a 0 and a comma. And then we add a 0. 5 into 3 goes 6 times. So 3/5 is actually 60%, 0.6. How about 4/5? So this is 80%. But let's see how it is, 0.8. So we are dividing 4 by 5. So 5 into 4 doesn't go. Put a 0 and a comma and add a 0. 5 into 40 will go 8 times. So 0.8, 80%. So that's that. So we're looking for a number that lies between 0.6 and 0.8. You can think of numbers like 0.65. You even think of 0.7, even 0.75, all the way to 0. You have an infinite number, amount of numbers here. But anyway, any number that looks like it's above 0.5 or 0.6, above 0.6, and below 0.79, let me add 0.79. All these numbers actually will be between the interval. So let's find out which of these fractions gives us a decimal like that. So which of these rational numbers, give us that. So let's start with A. So starting with A, we do have 7 divided by 5. So 7 inside the house and 5 outside. So 5 into 7 goes really one time, put a comma, and then 1 times 5 is 5, 7 minus 5 is 2. So we put a 2 here and then add a 0. And then 5 into 20 goes 4 times. So 1.4. We ask ourselves a question. Does 1.4 lie between this interval of 0.61? Let's put 0.61 indeed, which is part of this interval. Does it lie between 0.61 to 0.79? Nope. So we know that A is not part of what we're looking for. And let's go for B, which is 5 over 8. Okay, so we're dividing 5 by 8. So the first thing we say is 8 doesn't go into 5, so 0. And then we put a 0 onto 5. So 8 goes into 50. How many times? Think about 48. I believe that in 48, 8 goes 6 times, right? Because 5 times is 40. So yeah, 6 times 48. So we put a 6. Boom. Well, so this is interesting. A rational number between. So this is like on the verge. So 6 times 8 will be 48. 50 minus 48 gives us 2. Boom. And then we add a 0. Now, 8 into 20. 8 into 20 goes 2 times into 16, right? Twice. So 2 times 8, 16. 20 minus 16 gives us 4. We put a 4 here, we add a 0. Finally, we say 8 into 40 goes 5 times. So look at the number that we get here. Here in B, we do get 0.625. The question we ask is, does 0.25 lie between this interval of 0.6 up to 0.8? It does. So this is that number that we're looking for. Let's just check C. Now let's check the line C. Now 4 over 3. 4 over 3 will give us 1 point something. So it's definitely not the answer that we're looking for. But let's do it. We're dividing 4 by 3. 3 into 4 goes once, put a point, a comma, add a 0. 3 into 40, we now know that it goes 13 times into 39. So if we say, what did I do here? So, okay, 3 into 4 goes 1 time, 1 times 3, okay, 40, 4 minus 3 is 1. So 3 into 10, written method is not very easy. 3 into 10 goes 3 times. 3 times 3 is 9. So now we say 10 minus 9, that gives us 1. So we can keep on going on here. We put another 0 here, so it's 1.3. It's a recurring decimal. This recurring decimal, it is a rational number, but it's not the one that we're looking for. It's not between 0.6. So bam, it's not. Let's go for D. We know D shouldn't be also. If we understand that it's only one answer is correct here. So far we found that to be B. Let's find out 4 over 10. So we're dividing 4 by 10. 4 over 10 is like 40%, right? So let's check. So 10 into 4 doesn't go. Put a 0 in a comma and then add a 0. 4 into 40 goes 4 times. Good. 40%, 0.4. Does it lie between this interval? Doesn't. So it's not. So the correct answer here, class, happens to be B, which is 7 over, what is it? What am I working with? No. We're working on question, this is question 4, right? No, this is question 3. Rational number between 2.5. So the correct answer is B, indeed, 7 over 10. Why 7 over 10? Because I don't see us. No, class, something happened here. Something happened here. I think I solved the question. I solved B from 5 over 8. So this is so funny. So let me just remove this. But okay, obviously, it tends to lead us to C. C seems to be the correct answer just because we didn't do it, and it will give us the answer that is missing. So let's just do 7 over 10. So we're dividing 7 by 10. That's 70%. So it's correct indeed. So 10 into 7 doesn't go 0 point. Put a 0. 10 into 7 goes 7 times. Boom. 7 times 10 is 70. 70 minus 7 is 0. So as well, 0.7 is the correct answer. Still, B still happens to be the correct answer. But I had actually calculated 4B instead of 3B. But okay, luckily, it still fits. So that is why, to avoid this type of blunder, we are going to do something different here. Let's move this question, the rest of this question. We will move it downwards here so that we can avoid mixing myself up. So how do I do this? I can perhaps move A and B alone. A and B, stick them up right here. Can't help keep C and D, whatever they are. Oh, but I could move C, put it below B. I could move C and put it here. That still works for me. Good. And that allows me actually to move 4 up here, kind of isolate it here, avoiding the mix-up. All right, so it gives me space to also drag 5 down here. Boom. So now let's deal with this one. A rational number between 1 over 2 and 3 over 4. That's like a half and a 75% and a 3/4. So that's like a rational number between, we know that 1 over 2 is the same as 0.5. And all the way, it has to be a number between 0.5 and 3 over 4, which is 0.75. Why do we know this? Of course, we know this because if you divide 1 by 2, you will say 2 into 1 doesn't go with a 0 comma, add a 0. 2 into 10 goes 5 times. 5 times 2 is 10. 10 minus 10 is 0. So that's 0.5. And of course, you know that 3 over 4 is 0.75 or 75% by dividing 3 into 4. So 4 into 3 doesn't go 0 point, add a 0. 4 into 30 goes 7 times into 28. 7 times 4 is 28. 30 minus 28 is 2. Put a 2 here, add a 0. 4 into 20 goes 5 times. And 5 times 4 is 20. 20 minus 20 is 0. So, okay, we know that we're dealing with the number between 0.5 and 0.75. Let's just find out which of these numbers lies between that interval. So let's start with A. Starting with A, it's 2 over 5. So we are dividing 2 by 5. Written method. So this method is very fancy. It's not like the long division method. So 5 into 2 doesn't go 0 point. Add a 0. 5 into 2 goes 4 times. Ooh, so we're dealing with what? 40%. 0.4. Does it lie between 0.5 and 0.75? Nope, it doesn't. So B, 5 over 8. Okay, let's not guess. Let's just do it. So we're dividing 5 by 8. 8 into 5 obviously doesn't go 0 point, and then add a 0. 8 into 5 into 50, we know that it goes 6 times because of 48. So, okay, 0.6. 6 times 8, that's 48. 50 minus 48 is 2. Put a 2 here, add a 0. Ask yourself a question. 8 into 20 goes 2 times into 16. 2 times 16, that's 2 times 8, that's 16. 20 minus 16, that's 4. Put a 4 here. Ask again a question. 8 into 40, 8 into 40, 40 times, 8 times 5 is 40. So it goes 5 times. 5 times 8, that's 40. 40 minus 40, 0. So this is, okay. Does it lie between 0.5 and 0.75? Bing! Yes, it does. What about C? Now, C is 4 over 3. We know that 4 over 3, this is an improper fraction. So it's improper fraction. That means it will give us a whole number and a fraction, a mixed number, right? So obviously it doesn't lie between 0.5 and 0.75, but let's do it for the sake of, doing it. So you are dividing 4 by 3. 3 into 4 goes once, okay, put a comma. 1 times 3, that gives us 3. 4 times 3, 4 minus 3, that gives us 1. That comes here and add a 0. 3 into 10 goes 3 times. 3 times 3 is 9. So 10 minus 9, that gives us 1. Oh, add a 0. And then again, 3 into 10 goes 3 times. So this is another recurring situation. So it's 1.3333. Does it lie between 0.5 and 0.75? No. Gang. So lastly, we deal with D. 1 over 4. 1 over 4, we know that to be 0.25. Too small to be part of 0.5 to 0.75, but let's do it. So we're dividing 1 into 4 pieces. 4 into 1 doesn't go 0 point. Add a 0. 4 into 10 goes twice. 2 times 4, 8. 10 minus 8, that gives us 2. We put it here and add a 0. 4 into 20 goes 5 times. 5 times 4 is 20. 20 minus 20 is 0. So indeed, 0 0.4, which 0.25 is equal to 1 quarter. So 25%. So this is also not part of our answer. So the correct answer here indeed is B. Wasn't B the correct answer in the last question? Yeah, there's a pattern here. It's B, right? Okay, that's interesting. So let's just do this. Let's just do the last one. So this is a very interesting question. Question 5. Which one of the following is not a rational number? So let's start with A. Let's analyze A. What do we find out? We find out it's the square root of 2. So when we look at the square root of 2, well, that's a very complicated one. But we know that if we like choose 1 over 4, 1.4 multiplied by 1.4, that's a square. We say 4 times 4 is 16, carry 1. 4 times 4 is 4, but 1 is 5, 6. And we put a 0 here, and then we say 1 times 4 is 4. 1 times 1 is 1. And we add all this up, you have 1.6. This is 9. And then 1.5 goes at 2 decimal places. 1.96. You can see that 1.96 is closer to 2. So basically, the numbers that give us that give us the square 2 or the square root of 2 should be 1.9 something. Now, looking at this number, the question is which of the following is not a rational number? Well, can you write 1.96 as a fraction? Oh, you cannot. So this is one of the answers. AX happens to be one of the answers. Can't write it as a fraction. Now let's look at B. 0. Is 0 a rational number? Well, if you think about it, 0 can be equal to 0 over 1. So you can write it as a fraction. It is a rational number. Funny, but it is. Now, what about C? C, the square root of 4, we all know that is 2. 2 times 2 is 4. Can you write 2 as a fraction? Well, you can actually write 2 as a fraction. 2 over 1. So it is a rational number. Now, what about which of the following is not a rational number? Oh, so looking at D, square root of a negative number, negative 16. So we know that this is not a real number. So not real. It's not a real number. Actually, it's called an imaginary number. You'll learn this in the future if you continue with a lot of mathematics or engineering. So it's an imaginary number. So now we just say we can't find a square root of a negative number. For now, you can't find, until you get your superpowers as you pass, can't find the square root of a negative number. You can find the square root of a negative number. So that's how you answer this one. So we're looking back. This can be written as a fraction. So it is a rational number. This is a rational number. So this actually negative of a square root, it's not neither real number, so it can't even be a rational number. So we leave it as it's not. So the correct answer is A. The correct answer here happens to be A. Now let's move on to question 6, because I believe we do have more questions here. So we have question 6 to deal with. Suspecting here we may have issues with space. So let me just expand preemptively our canvas. So here our canvas is expanded. So let's tackle these questions head on, one by one. So question 6. Okay, question 6 wants to know which one of the following is an irrational number, so not a rational number, cannot be written as a fraction. So square root of square root of 4a, we know that is 2, and 2 can also be equal to 2 over 1, which is a fraction. So this one is a rational number. It's not an irrational number. So we go to B, and in B we say, 3 times the square root of 8. That's very interesting. Irrational number. Square root of 8 is an irrational number. Why? Square root of 8 what number gives us 8 when we square them? 2 times 2 is 4. So 3 times 3 is 9. So there's a number between 2 and 3 that when we multiply them, they should give us 8. Let's take, for example, 2.4 times 2.4. And we say 4 times 4 is 16. Again, carry 1. 4 times 2 is 8 plus 1 is 9. Then add a 0. And let's say 2 times 4 is 8. And then 2 times 2 is 4. So here, this is strange. What did I say? It says, is it a number between 2 and 3? Yeah. So I guess it's got to be a greater number than 2.4. 6. And then here you have what? You have 17, carry 1. So 5, too many, 2 decimal places. So 5.75. That's not 8. That's very far from 8. So let's just undo this and choose a bigger number. I'm thinking of right now 7, so that we can just go big and get closer to our 8. I'm just giving us an idea what type of number comes out from this. So 7 times 7 is 49. So carry 4 here. 7 times 2 is 14 plus 4, that's 18. Carry on, okay. And then put a 0 here. And then 2 times 4 is 14. 2 times 7, I mean, is 14. Carry 1. 2 times 2 is 4 plus 1 is 5. Okay, so we are getting closer, but not quite there. What you have here now, you have what? 2 carry 1. Oh, 7.29. That's very close to 8, but not quite. Let's just try out now 2.8. I didn't know that the square root of 8 is quite close to the square root of 9. So now 8 times 8, that's 64, carry 6. 8 times 2, that's 16 plus 6. 16 plus 6 is 22. So put 2 and 2, and then put a 0. 2 times 8, that's 16, carry 1. 2 times 2 is 4, plus 1 is 5. So that gives you like 4 here, and then 8 here, and then here 7. 7.8 is quite close to 8. Acceptably close, okay? Now, a number like this, can it be written as a fraction? Doesn't look to me like that. You cannot write this number as a fraction. Again, even if you multiply it by 3, obviously you're just puffing it up, but you can't really write it as a fraction. So I believe that 2 is the correct answer, is an irrational number. Now let's check. The square root of 100 is 10. 10 can be written, square root of 100 is 10, because we know that 10 times 10 is 100. So that's a square. And 10 can be written as 10 over 1. So of course, this is a rational number. So this is not part of our answers. And what do you say for A? The same thing. Now, let's move on. I'm beginning to feel like we need to move question 7 downwards. So that's what we're going to do. We're going to move question 7 down here to give us space to work with. So question 7. So question 7, decimal representation of 1 over 5 is, I know this by heart, it should be 0.2, 20%. It's 20%, y'all. So let's calculate it. Okay, in fact, before we calculate A, we just calculate what we know. So 1 divided by 5, I say it's 20% or 0.2. So that means you're dividing number 1 by 5. So say 5 into 1 doesn't go with the 0 and a point. Add a 0, 5 into 10, it goes 2 times. 2 times 5, 10. 10 minus 10, 0. So 0.2 represents 1 over 5. So which one does that? The first one, A. A does that. 0.5 is the representation of 1 over 2, so it's not. 0.02, must be the representation of 1 over 50, if we think of the logic here, so it's not. So this is 1 over 50, not 1 over 5. 0.02 can only be the representation of 1 over 500. You see, there's a logic into this. So the correct answer here is A. So let's move on to question 8. Now, question 8, oops, let's copy it from here. Question 8, move it down a little bit so we can get some space. So question 8, 3 and 3/8 is decimal form of, okay, so whatever number that we're given here should have 3 first, right? So we have 3 whole numbers followed by 3/8 by fraction. So we can see that here we have a whole number that's 33. So C is wrong. It's not part of the one we're looking for. Neither is D, 237 over 5. So we can now try to find out between between A and B. And I can tell you from experience that this B, I've done 3 over 8 quite some time, for some time, to think that it's actually, I might be wrong. 0.375. But okay, let's find it out. So let's just say 3 divided by 8. 8 into 3 doesn't go 0 point. 8 into 30, it does go about 7 times. Huh? Wait a minute. It's 8 times 8. It goes 3 times, it goes into 24. So 3 times. 3 times 8, that gives us 24. And 30 minus 24 gives us 6, which we place here. Put a 6 here and put a 0 here. Then we ask our next question. 8 into 60 goes how many times? I know that 8 goes 8 times into 64, which means it will go 7 times into 60. Let's try that out. So go 7 times. But now, 7 times 8 gives us what? We know that 6 times 8 gives us 48. So 48 plus 8 should give us 56. 56, okay, that's a number. 60 minus 56 gives us 4, where we throw 4 here and put a 0 here. And now 8 into 40 goes 5 times. Boom! So we have the number. It's 0.375. I guess I was guessing correctly. So the answer here happens to be B. Of course, it cannot be A, because obviously when you divide 3 by 8, you get 375. So it's not A, it's B. Very good. So we guessed well by first calculating this and then answering that the correct answer should be B. Now let's move on to question 9, our second last question. Question 9 says 5 over 6 is the decimal form of which of these? Okay, what do these numbers in the options mean? These numbers, I want to take a guess, that means recurring decimals. I remember that we put a point, a dot in some cases. So here we're putting a line. It means that these numbers that have been placed with a line may be recurring. That's what I'm thinking right now. Just logic, depending on different books. But anyway, let's go to 9. So we're doing question 9, which says 5 over 6. Let's find out 5 over 6 first. 5 over 6 is the same thing as dividing 5 by 6. Put 5 in the house, put 6 outside. So we're dividing 5 by 6. So we say 6 into 5 doesn't go, obviously, 0 point. Then we add a 0. And then 6 into 50 goes how many times? It should go into 48 8 times. So 8. 8 times 6, that's 48. 50 minus 48 gives us a 2, which we put here and add a 0. 6 into 20 should go 3 times into 18. So 3 times. 3 times 6, 18. 20 minus 18, that gives us 2 again. Boom. You see? Recurring. As we add a 0 again, we will say 6 into 20 goes 3 times. 3 times 6 will give us 18, 20. So you see that the 3 keeps recurring. This will go on forever. This will go on forever, folks. So in our curriculum syllabus, we put a dot here. Apparently in this book, you put a line, so it's okay. So the number we're looking for is 0.8 and a 3 that keeps on repeating. Now I'm a little bit confused because they put a repetition of 1, 3, and then they put a repetition of various 3s. So this is a bit confusing. Who repeats here? So, okay. First of all, we can say that we know that D and C are out of the question. Now, I'm a bit skeptical. Who keeps repeating here is actually 3. So A is the correct answer. B cannot be the correct answer because they're talking about repetition of double digits. So this doesn't make sense, We're not repeating 30. We're repeating 3s here. We're repeating 3. So that's the correct answer, A, for sure. Now, we move on to the last question. The last question is 10. Last question is 10. Decimal representation of the rational number. So they're telling us the rational number because, of course, if you can write it as a fraction as 8 over 27 or 8/27ths, it means that it is a rational number. Now, which one is the decimal representation? Let's do it. Let's just divide 8 by 27. So we put 8 inside the house, put 27 outside. And of course, 27 doesn't go into 8, so we put a 0 and a comma. And then, of course, we're forced to add a 0. Now, we know that 27 does it go 3 times into 81? Maybe, but okay, let's just say 2 times because I know for sure. 2 times 27 will be 54. Yes, 50. Let me just 27 times 2. 2 times this will be 4. 14, and then 2 times this will be 4 plus 1. It's 54 indeed. So 2 times this will be 54. 80 minus 54, I cannot subtract that quickly over my head. Then allow me to use this. So 10 minus 4 is 6. 7 minus 5 is 20. So, okay. So 80 minus 54 is 26, which we are allowed to put here. 26. And then put a 0. So now 27 into 260. If it was 270, it will go 10 times. But since it's 260, I want to vouch for 9 times. And then I can say 9 times 27. And then I don't know that, so I can come here and say 9 times 27. Calculate that quickly. I know that 9 times 27 is 63. I use my fingers. So 63. So 9 times 2 is 18 plus 6, that is 24. So 243. So 9 times 27 is 243. 260 minus 243. Oh, written method is interesting when the numbers are complicated. So now you have a 5 here, Carol. So 7. 5 times 4 is 1. So 260 minus 243 is 17. So you see here, we have a 17 and then put a 0. So now we are talking about how many times does 27 go into 170? We can do that. We should do that. So how do we do that? We add 27, 27, 27 until we get to 170. But for now, you can see that the answer that we're looking for should be 0.29 something. Let's come back here to our options. So here in our options, we have 0.29, 0.29, 0.296. Oh, interesting. So we still have to work, family. We still do have to work. So let's just find out how many times 27 goes into 170. That's what we're looking for, 170. So there's no other way. Since we're not using any calculator, the way we do it is indeed we just try to figure out how many times. So we notice that, let's just see, 2 times 27 is 54. Okay, let's start from there. So there are, in 54, you have two of these 27s, right? Now it means that in 108, you have 4 of them. And then if you add another 27, so you have 5 of them, you will get 5 here, carry 1, 3. In 139, you have 5 of them. You get my drift here? So in 139, in 35, you got 5 27s. We're looking for the number of 27s in 170. So let's move on. Let's continue. So let's add another 27. So this is the last part of our problem. So we say 135 plus 27. So that gives us what? That gives us 162. Good. So we have what? 6 27s in 162. That's good enough. So we come back here, we put a 6, 296. So 6 times 27, of course, gives us 162. And then 170 minus 162 gives us 8, which we have to put somewhere here. So let me just find some space. Let me just clear this out here. Let me just clear this. I don't need this for now. We have a 2 that we just got from here. So we say what? We say 170 minus 162. We have an 8, actually, not a 2. So let's put this 8 here. And when we had a 0, seems like we have gotten back to where we started. So if we have 80, again, we know that it will go 2 times, right? And then 2 times 27 gives us 54. 54, 80 minus 54 will give us 26. which again we put here 260, and then again we add a 0, and then we go down the same rabbit hole, 9, and then 9 times 27. It will take us back to the whole process. So here we can safely say that what keeps on repeating is 296. So 296 is repeating. Not 6, not just 6, it's 296. These three numbers keep repeating. So here it's not 96, no. This is not wrong, this is not correct. So A is the correct answer, because we have deduced that the 296 will be recurring, right? As you can see here. As you can see from what we just did here, this will keep on repeating, 296. Same rabbit hole. So that is it, folks. That is it, friends. This is how you find out your rational number calculation. Only thing that you need to remember, you have to remember that rational numbers have to be able to be written in fraction format. Of course, they have to be real numbers, just so that if you have a square root of a negative number, obviously they are not working with no rational or irrational number. That's that's like not a real number. And what else? Yeah, even 0 can be a rational number, because you can write 0 over 1. That's a fraction, so it can be expressed as a rational number. Interestingly, even whole numbers are rational numbers, because you can say 2 over 1, 5 over 1, so you can write it as a fraction. So rational number keywords can write it as a fraction. Interestingly, isn't it? Now, repetitive or recurring decimals may come from rational numbers. For example, 1 over 3 gives us 0.33 forever. It's a recurring, but it is a rational number, so it's good to remember that also. Thank you, folks. As usual, you can like, subscribe, and comment on this. See you next time. Rational numbers that can be written as a fraction. Rational numbers that can be written as a division of numbers. Rational numbers are numbers that can be written as a fraction. Rational numbers that can be written as a fraction. Rational numbers write as a fraction, writing these numbers. Rational numbers write as a fraction, as rational numbers. Rational numbers write as a fraction, writing these numbers. Rational numbers. Rational numbers.